Welcome to the Cultivation Cast by Black Dog LED with Kevin and Noah. In this podcast, we cover all things related to indoor cannabis cultivation. We continue to receive feedback from our listeners, which is incredibly helpful to understand which topics you want us to cover, what things you'd like us to talk about, and anything like that. So please keep that coming back to us at podcast@blackdogled.com via email, or of course you can reach out to us through social media or call us or do anything you want. But if you want to send a direct email about the podcast, you can use podcast@blackdogled.com. So today, just a heads up and a bit of a warning for those of you that aren't technically inclined, this is going to be a slightly more technical conversation. There's no way to get away from it because we're going to talk about some of the new stuff we literally invented for Phytomax 3. And there's no way to talk about that without doing a little bit of a deep dive. We've got Kevin here to do that. We'll try and keep it as high level and relatable as possible to everyone, but it will get a little technical on the electrical side today. So let's dive right in and talk about what we've done, some of the new things we've done, and one of our bigger changes with Phytomax 3 and why we had to do it and what it is. And that's really our power supply. So let's start at the very basic by talking about drivers. What are drivers? Why do we have them? When we call them drivers, you could call them different things. They could be called power converters or different things. In the old days of CFL, it might be called a ballast almost. So what we're doing essentially is converting AC to DC. And Kevin can explain why we really do need that with LED. So Kevin, why don't you walk us through just fundamentally, why do we have drivers in an LED light and what do they do?
So drivers are basically simply power converters. They're taking alternating current and converting it into direct current. So instead of having your voltage do this sine wave, it's just a constant flat line, which is providing constant power to the LEDs. Now, LEDs are somewhat unique. I mean, probably everyone has a cell phone charger, something that they can plug into their vehicle's cigarette lighter. That's actually a constant voltage source. It's providing constant 12-volt output, regardless of what the current, the amount of electricity going through there is. It's always being pushed through at the same 12 volts.
And so that's a great point. So most of us, almost every electrical device we use, whether it's my phone, my laptop, we all have that wall wart, we call them, something we plug in. And that is essentially a driver almost, right? It's converting AC to DC at a fundamental level.
It is, yes. It's a simple AC to DC converter. However, most of those are constant voltage. The problem with constant voltage power supplies for LEDs is that as LEDs warm up, as they start getting used, the voltage that they require to light up actually drops. So if you're providing them with a constant voltage, that constant voltage driver is actually going to continue pushing with the same voltage all the time. But as the voltage the LED requires drops, it ends up pushing more and more and more current through. And this can lead to a runaway burnout situation where the LED can actually end up taking way too much current and frying the entire LED. So that's why quality LEDs, at least when you're making a large fixture of them, and if you really care about them lasting for a long time, you really do want a constant current LED solution to ensure that the power converter is providing a constant amount of electrons flowing through and varying the voltage to keep that amount of electrons flowing through the same so that you're not burning out the LEDs.
Gotcha. So would it be a true statement to say that every LED light fixture on the market today for growing plants, let's say, does have drivers inside of it? So it's a component we all kind of need.
So yes and no. There's also something called direct AC rectification, which basically, instead of converting alternating current to direct current, what it's doing, because LEDs can only accept electrons flowing through them in one direction. If you try and push them through the other direction, it'll actually fry the LED 100% of the time. So the problem with alternating current is it's pushing the electrons one direction and then pulling them back the other direction 60 or 50 times a second, depending on where in the world you are. And so you can't just plug an LED into alternating current. It will destroy it within 1/60th of a second. So direct AC rectification actually works on a process where they kind of invert the voltage. Well, there's multiple different ways they can do it, but sometimes they just say, okay, we're only going to give the LEDs the electrons that are flowing in one direction, so it's 50% efficient. It's only giving the LEDs the positive voltage. There are tricks that they can do to make it reverse the voltage when the AC sine wave is down below where it should be, for the LEDs at least. But the direct AC rectification is very cheap. It's by far the cheapest way. It's much less expensive than these AC to DC converters, but they're inherently less efficient. The most efficient ones you can get are about 80% efficient.
And that's something that's going to be a bit of a theme for this topic is, if you didn't care about efficiency like we do, there are other ways to deal with sort of the challenge that we faced when dealing with the new Phytomax 3 and some of the things we had to overcome that drove this innovation and this invention. One of the things that we talk about all the time is, for example, I might not care in an office setting if I have a light that's 40% less efficient because I'm dealing with very small amounts of light.
If it's 4 watts and 40% less efficient means it takes 6 watts, big deal, it's 6 watts. If you've got a 1,000-watt fixture, 40% efficiency gain is huge. That's 400 watts.
Well, the other thing is we know it's somewhat linear, the efficiency and the amount of photons we're going to get out of the yield. So if we take away efficiency, we take away some of the photons we're going to get for that input of energy, we are taking away yield from our customers or from the potential yield from their light. So to us, efficiency correlates to yield, which to our customers can correlate to their yield in their home grow or to dollars if it's a commercial grow directly. So to us, a couple percent efficiency makes a big difference, but in a normal fixture for an office or a ballpark, that's not really going to matter quite as much, right? So now we've got efficiency questions. We understand a bit about driver. Let's talk about the problem we ran into that's inherent to Black Dog because our spectrum is unique. You know, other companies are running all white, we call basic white spectrums. They're running all white, maybe doping with some red LEDs to get a decent flower set, and that's about it. It's a very basic spectrum, whereas we're using multiple different LEDs to build our spectrum. So why does using multiple different LEDs now cause us a problem with drivers, Kevin?
Well, so it gets even more complicated because there's literally thousands of different kinds of LEDs out there on the market. In general, they are divided into low power, mid power, and high power LEDs, depending on the total amount of wattage each LED can actually handle. For decades, low power LEDs were all that were available, but in the past 20 years, we've gotten to where the mid power, which tend to be your 3 watt-ish type LEDs, are now available and even very efficient in some cases. And then there's high power LEDs, which tend to be the 5, 10, there's even some that are 15, 20 watt LEDs now that traditionally have been extremely expensive or not as efficient. But in some cases, sometimes those high power LEDs are actually the most efficient for their particular color or wavelength. And then in other cases, the mid power LEDs are the most efficient for their particular wavelength. And when you're dealing with 2 or 3 different power classes of LEDs, the problem is you need to provide them with different constant current inputs to ensure that they keep working at their peak efficiency, number one. You don't want to be overdriving the mid-power LEDs and giving them the same current you're giving the high-power LEDs, because you're going to fry the mid-power LEDs pretty quickly that way. It might work for a year or two, but they're going to fail on you. Plus, they're most efficient at a particular current level. And so we're using 8 different colors of LEDs. They each have a different optimal region for the current that should be pushed through them so that they're putting out as many photons per watt as absolutely possible.
Gotcha. So by having that and having these different color LEDs and those different needs, it causes a challenge because when you go to buy a driver, which we design for years now, we've had our own drivers because if you buy off the shelf, you're getting a lot of things you don't need. You're kind of buying a driver that's designed for the masses. Whereas if you design your own, if you have a very specific need, you design your own. So normally we would just go and design our own driver, get a driver built the way we want, and have one efficient driver to run our various lights. But now
at one current.
One current.
But that, with Phytomax 3, we wanted to push efficiency to the absolute maximum. So we started off with a 94% efficient driver. 94% efficiency in a constant current driver is pretty much the best you can get on the market. There are some slightly higher efficiency drivers, but they're actually not as safe. They're called non-isolated drivers, and they can be very dangerous. So we're not using those. We're using 94% efficient constant current drivers that are actually capable of running our LEDs on our LED boards at multiple different currents. So that's where we're switching out and doing something I don't believe anyone else in the market is doing, where we're running each of our LEDs at its ideal constant current input to ensure that it's running at peak efficiency for that particular color.
Now, to be clear, for those of our listeners that are versed in drivers out there and know what's available, yes, there are multi-channel drivers you can buy. So we are not talking about a multi-channel solution here, to be clear. A multi-channel driver is going to say you could have 3 different channels. All it's saying is they've kind of built 3 drivers into one housing and they're giving you 3 different settings or a 2-channel driver. So to be clear, that's already out there. That exists. But now I have different channels, and now I'm dealing with basically I could do the same thing by buying 2 different drivers at a different current and putting them in a unit, or buying a 1 multi-channel driver. Nothing unique there. This is unique. Why? Because this is not a multi-channel driver. So why is this really different than what's already out there? And why are we patent pending on this now?
Because we're actually using one driver to run multiple different strings of LEDs at different currents. And so with the alternative option, which is using multiple different kinds of drivers, number one, that starts getting very expensive because you have to literally have 2 or 3 different drivers in even our smallest 100-watt light just to get the appropriate currents for each of the LED strings. Number 2, it's very difficult to optimize the efficiency for all of those at a decent price point. It can all be done. If you pay enough money, almost anything can get done, but within the boundaries of the laws of physics. So what makes this unique is it's a cost-effective way for us to be able to optimally drive all of our LEDs at their optimal current. And there are other solutions for this class of problem. A lot of our competitors that are using that red and white spectrum will just run a bunch of white LEDs in a string in parallel with each other. So they're dividing up the current between each string of white LEDs, and then they combine that back and they're running fewer red LEDs, which are higher power LEDs, in parallel with each other. The problem is if one of those LEDs, either a white or a red, burns out for whatever reason, it forces the other LEDs that are running in parallel with it to take a higher current. Now that might look like a good thing because it means that if one LED happens to burn out, hey, the other LEDs just automatically got brighter to make up for it. The problem is it's a feedback mechanism. It's a self-reinforcing feedback loop where once one LED dies for whatever reason, it's starting to overdrive the rest of the LEDs, which just increases and accelerates the likelihood that they're going to fail. So when the second LED fails, then it really increases the chance that the third one's going to fail. So it leads to a runaway effect that can destroy the entire light, actually. So one of the things that's very unique about what we're doing is we're actually ensuring that all of our LEDs are run in series with each other so that they're always getting the same constant current. And even if one does fail, what we're using is what's called a bypass diode to route electricity around that LED. So unlike an old-timey string of Christmas lights where if one comes out, you lose your entire string, the bypass diodes allow the light to continue working if one LED goes out. However, we don't then start overdriving the rest of the LEDs to make up for that. So we've designed this light to continue working for years, decades to come.
Yeah. So like you said, all of these things are possible. I mean, one, our new invention on the driver that's now patent pending, that's unique to us. But the bypass diodes, those are available on the market. But most of our competitors don't use them, right? They're just not. Why?
It's an additional expense, number one. They choose not to put them in their circuit because they can make a cheaper light without it. And if by running their LEDs in parallel with each other, they can ensure that the light continues working well enough for a while that you probably won't have an issue with it until several years down the road, 2 or 3 years down the road. And then by that time, most of our competitors actually have gone out of business, typically. So
what they're doing by balancing, you could almost say they're sort of trying to balance their driver on the board by using LEDs to balance their circuits or their electrical driving system, versus us, we're doing it on the driver side, which we'd argue is the better way to do it. I'm doing it at the source. I'm taking care of my load versus trying to kind of jury rig it down the pipe on the board side.
Correct. We are always running all of our LEDs at a constant current. There is no failure that can happen, whether it's the one LED failing or anything else happening in the light that would cause LEDs to suddenly get more current than we designed them to take.
I got it, got it. So to sum it up, really, what we're talking about is what we've got is a unique design that's patent pending, and what it's really doing for us is it's allowing us to optimize the electrical and also the monetary costs of our lights, right? So we're making them as efficient as possible, which is what we're always chasing, because an increase in efficiency is an increase in profitability for our customers that are commercial. And if we're chasing that, we can get them a little more efficiency. That's good for us, good for them. So we've got a more efficient system from an electrical standpoint, which kind of works its way down to their profitability. And then on the other side, there's also a monetary efficiency in that we can build this light that efficient for less cost instead of buying 3 different drivers or 2 different drivers per board. By having to optimize, we're optimizing at the driver. So now we've got a slightly more cost-effective solution than if we went using a off-the-shelf solution, if you will.
Correct.
All right, well, we're understanding that a bit. So it's fascinating that this is a problem that while we've used different LEDs for a while, as Kevin said, one of the challenges is that LED technology is progressing. And some people watching or listening to this might say, well, if it's such a cool, great idea, how come you're the first? Why did you guys think of this? You guys are a LED grow light company. There's this massive Osram and Cree and these big LED companies that haven't done that. Well, part of it is the efficiency thing. From our perspective is if you are working on headlights or lighting for an office building or for a parking lot, and you don't care about that little efficiency hit, there would never be a reason to do this. But if you're running multiple different colors and you're trying to be as efficient as possible at a system level, then it sort of drives a need for this, whereas someone else wouldn't have needed that for 2 reasons. One, because they don't care about efficiency like us, and unlike most our competitors and other applications of LEDs, they're not running so many disparate colors, right? They might be running RGB, right? They're running a few colors, not all the different colors we're running.
Correct. And in the past, most of the LED fixtures on the market that are running more than 1 or 2 colors have typically been a one-size-fits-all. It's also very fixed, and you get the 650 watt fixture and there is no other option. And that's because they have different drivers in there perhaps to try and fix the problem for them, but that fixes them also into one particular size because they've got 1 or 2 or 3 different drivers in there of a particular wattage, one for each color that they're running. And we wanted more flexibility because we recognize we've been growing for long enough and doing this long enough that one size does not fit all in grow lights. You need to have flexibility. Sometimes you need a cloning light. There's no need to run 1200 watts for a cloning light. At the same time, we wanted to preserve the same spectrum rather than just saying, oh, well, if you want the good spectrum, that's only available on our large light. Here's a cheap little light that doesn't have the same spectrum that you can use for cloning, which is what most of our competition is doing. So we wanted to ensure that you always get the same spectrum, always get the same benefits of always having ultraviolet all the way through your entire grow cycle, from clone all the way through flower, and be able to do that in many different sizes of light in an economic way that we can provide the best, longest lasting, most efficient solution possible.
Yeah, so it saves us money, makes us more efficient, and it provides scalability, the solution does. So, okay, so that's why it's unique and what drove us to need it versus other people that are using LED. And I would point out, LED is still a fairly new technology. It's not like incandescent bulbs where they've had time to develop things that have already been thought of long before us. We are on the cutting edge using stuff that other people haven't tried to put together yet into the same package. So by us combining these, it does create new challenges and problems that we're now trying to solve. And this is a really good solution. When you hit upon it, Kevin, and told me, I thought it was an amazing idea. And it has actually, we thought, wow, if it's this simple and what we came up with is this good of a clean idea, somebody thought about it, and we looked, no one has, and it's very unique. And we hope that it brings a lot more value to the product line with this new, unique patent pending technology. So to point out that what we've done here is not only help with that, but another thing we've talked about in this is that, yes, there are competitors that have other colors. They're using, let's say, whites and reds, but they're doing it in a way that is not optimized, and they're doing it in a way that will not have the longevity. Now, they could do that by adding, like Kevin said, adding bypass diodes. They're on the market. They could go buy those, but it would add cost to their fixture. And when you're trying to make a cheap light, an inexpensive light, if that's your driving force, well, then you're going to cut those corners. At Black Dog, we're more about, there's a major investment. We're going to want to grow with these for years. So we're not wasting money, but instead of cutting corners, we do lean into those and say, hey, what is the benefit of spending that little extra money? What do we get? A more stable system. Instead of lasting 3 years, it's going to last 7 years. That's the difference between cutting those corners and not cutting those corners, spending those extra few pennies on every diode to get those bypass diodes in there, right? And making that happen. So it is unique. Anything else you would add to what makes this unique to us, or why people are going to really enjoy this in PM3? Anything about, hey, what they're going to get is a more stable light. What they're getting with PM3 with this is it's a little lighter, it's a little more compact. I know our lights are much more compact than they were as part of that there. What are the other benefits that our growers might see in the real world? We're talking about this cool electrical stuff, but what about them? Is it, hey, now you get a smaller fixture. It's smaller and lighter to put in your tent.
It's definitely, I mean, we haul the lights around here all the time, packaging them up in boxes, and it's definitely nice having a smaller, lighter, large size light. And our new PM3 2S, the smallest 100 watt light, is regularly described as cute because it's so small around here.
Yes.
And yet it's currently being run in our R&D facility over a 4x4 foot area for clones, and it's kicking ass there. So just the additional power, the LED technology keeps getting better and better, so we keep getting more and more efficient. And that also does allow us to shrink the size of the fixture a little bit. If you are running in a tent at home, it's kind of annoying having a fixture that's the same size of your tent. It makes it very difficult to work in there. If you're running in a greenhouse, you don't want a giant fixture that's creating all sorts of shade. You want the most compact, brightest fixture you can possibly get to provide supplemental light without creating additional shading in your greenhouse. So we have some of the most power-dense LED grow light fixtures on the market at this point, which makes it easier to work with, easier to hang, doesn't block airflow, doesn't create problems with blocking airflow and other issues there. And in addition, unlike some of those 4 foot wide fixtures where you have to keep it really close to the tops of the plants, which sounds like a good idea, sounds like it's spreading the light out evenly, but when you actually start to try and grow with one, you realize that, having that fixture 6 inches above the top of your canopy makes it really difficult. Unless your canopy is perfectly flat, which almost never happens, you're going to have some colas that are higher than others. So most of them are either going to be outside of the ideal range, or you're going to have some that are sticking up into the light, and then they're getting fried by being too close to the light. And plus, it's just physically difficult to work around those things, to reach back in and deal with the plants. So it's nice having a nice compact fixture, but I think the quality, the efficiency that the new Phytomax 3 is really what at least our previous customers are going to notice a giant difference in, is just how much more light now you can get per watt.
Per watt, yeah, the efficiency is up there. And one other thing about those, when you're trying to grow with a fixture 6 inches off your canopy, what we've always struggled with is how does that really work in a real world cannabis situation where I've got hundreds of lights in a commercial grow, maybe even thousands, and I'm off a canopy that's growing an inch or two a day if I'm growing really well. How do I deal with that? So I'm sending people in or trying to have to set up a system to move my lights. We always believed the light should be an afterthought once they're in there. You should spec the right light, get it installed, and then forget about it. You shouldn't have to move it. It's up there, it turns on, turns off, and does its job year in, year out. You don't have to give it a lot of baiting and raising and lowering. It should just do its job. And that's kind of what we've gone with from our perspective in terms of design and how to set up a proper commercial grow room. So, all right, thank you for joining us today and listening. We hope you enjoyed this installment of Cultivation Cast. If you have any questions about what we covered today, would like to discuss this further, or have ideas for future episodes, please don't hesitate to email us at podcast@blackdogled.com. Thank you again for joining us, and happy gardening.